Okay, I'm working an example here from level 2, 7G1, exercise set 2. This is number 13. You're supposed to create a truth table to determine whether the following argument is valid or invalid. So in this argument, the first premise says if H, then J. Second premise says H, and the third premise says, not the third premise, the conclusion says J, therefore J. Now, here's how we're going to set up our truth table. First of all, in this whole argument, you've only got two basic elementary statements, elementary propositions, H and J. So you're going to have 4 lines, because what you're going to have is 2 raised to the power of the number of lines that the number of basic propositions you have, which is 2. So 2 squared is 4. Anyway, you got that, and then we're going to set up our under H and J, which are our basic elementary propositions. We're going to set up our true, true, false, false, true, false, true, false. That's the way we always do it, because that gives us every possible combination of truth values, and that's what we're interested in here. Now, what I've done here is you take each of the premises and you put them on the truth table. So here's my first premise: if H, then J, and I put a column here so we can determine the truth values of each of them. I highlighted the column under the horseshoe because the horseshoe is the main operator, and that column gives us the truth value of the whole premise, the truth values of the whole premise. And then I've got premise 2 is H, it's got its column here, and the conclusion is J, and it's got a column here. Now notice one thing, we've already got the H column truth values determined, and the J ones. So we can actually go ahead and copy. There's H, boom, that goes there, H, that goes there. They're exactly the same. And the same with J, right? So we can actually just go ahead and fill those in. The only one we really have to stop and think about here is the horseshoe, the truth values for the horseshoe, okay? So with a horseshoe, a conditional statement, this column is going to be true in every instance except if the thing that comes first, in this case H, is true, but then the second one, J, is false. In every other case, it's true. The truth value is true. So in this case, we've got if true, then true. Well, that's true. Now we've got if true, then false. That's false. Now we've got if false, then true. That's actually true for a conditional statement. Look, what if I say, let me just explain this for a second. What if I say, if it's raining, then the streets are wet? Well, that's great. But even if it's not raining, the streets may also be wet. That's totally compatible with what I just said. If it's raining, then the streets are wet. So conditional statement, if you got if false, then true, it's still true. And if you got if false, then false, that's also true. Okay, so here's the truth values for our main operator here. We've got the whole truth table worked out, right? Now, how do we figure out if the argument is valid or not? Well, here's what you're looking for. The argument is valid if, whenever all the premises are true, the conclusion is true. And it's invalid if we ever find a line where both the premises are true, but the conclusion is false. So let's work through this. I'm going to highlight for you this line. Here's the columns that we're interested in. Let's look at the first line here. Premise 1 is true. H, premise 2, is also true. Okay, now is the conclusion J true? Yes, it is. So this line checks out. So far, the argument's valid. Let's see if it holds up. Now we've got a case where, this premise is false. Well, if one of the premises is false, then it doesn't matter if the conclusion is true or false. That line does not invalidate. It's valid, okay? Because it only becomes invalid if the premises are all true and then the conclusion is false. But if the premise is false and the conclusion be true or false, it doesn't matter. It's still valid. All right, let's look at line 3. We've got true premise under here, false premise, so it doesn't matter. It's going to be valid. This is not a problem. So far, we're valid. And then we've got true premise, false premise, so valid. We haven't come up with any line where this column was true and this column was true under H, and yet J, the conclusion, was false. We didn't come up with any such lines. So that means that this argument is valid. That's what our truth table showed us.